This is a tale of three worlds. In two of those worlds, things went horribly wrong. But in one of those worlds, things went right. At least, they were going right. But now, not so much. Though maybe we could learn something from those two worlds where things went horribly wrong, and do something to help that third lonely little world. And it is because of that we are telling this story. So perhaps this is really the tale of one world. But perhaps I'm getting ahead of myself. After all, those three worlds are very far away from each other. So far, in fact, that one might ask, what could they possibly have to do with one another? We should take a closer look. This is Mars of the present, a dry and barren world of stony deserts, vast canyons, and windswept dunes. Dust storms like the one building right now often sweep over vast regions of the planet, sometimes enveloping the entire world, but never does a drop of rain fall. And yet, despite the view of this desiccated landscape, Mars was once a world of vast oceans and thick atmosphere, and in a time long lost in its past. It is very likely it could have supported life, even life such as we know it on Earth. Not only did it have oceans, but some of its more majestic features, like the gigantic Marineris Valley, a canyon the size of a continent, would have required as much as 100 Amazon rivers worth of water flowing through it to carve it out. Mars once possessed a lot of water. And for water to remain liquid, it requires a dense atmosphere, otherwise it sublimates directly into gas. This was once a world that was working, but it died over 3 billion years ago. So what happened to this once warm, wet, and promising world? What catastrophe befell Mars? Some 4.5 billion years ago, the red planet was formed. The early world was still very hot from the force of the material being rammed together under the force of its gravity, and the heat radiating from just beneath the crust is shown in this infrared image. Time passed, and Mars cooled. In that long-gone era, the solar system was swarmed by comets, and vastly more asteroids wandering in erratic orbits. Many of these were frozen, dusty chunks of ice. They fell into Mars, the same as they did with Earth and Venus, and over several 100 million years created the planet's vast rivers and seas. Its atmosphere thickened, it grew wet, it may very likely have rained, and in many ways it was much like Earth, though also its own world, which means also much unlike Earth, and those differences were to be its undoing. Because while Mars possesses 53% of the diameter of Earth, it has only 11% of our world's mass, and just a little over a third of our world's gravity. And these hinted at a fatal flaw lurking deep beneath the planet's crust. Its core, while probably nickel and iron like that of Earth, has many lighter elements and most likely far less radioactive elements than our world's core. Thus, the core could not maintain the heat necessary to keep it molten and active. But Mars also suffered some terrible luck. Roughly 300 million years after its formation, it was struck by an enormous asteroid, roughly the size of Ceres, the largest asteroid known in our star system, which blasted away an enormous amount of the crust from the planet's northern hemisphere, physically deformed the planet, probably produced both its moons, and may have disrupted the dynamo of its core, which once generated its magnetic field, sufficiently enough that the core could no longer fulfill that role, causing Mars' magnetic field to wither and die. It was a tragedy for the red planet, because over eons our star's solar wind buffeted the planet, first stripping away its atmosphere, and as the seas became more prone to evaporation as the air pressure lowered, The solar wind stole them away from Mars. The entire process probably took several hundred million years. NASA scientists believe that prior to the loss of Mars' magnetic field, the planet may have had conditions sufficient to host life. Even if there was never any life on Mars, the planet would certainly be friendlier to life now if this terrible event had never happened. In fact, 4 billion years ago the planet looked like this, a vibrant world of lakes and seas and waterfalls. And ultimately, as its atmosphere and water were lost, the little red planet at the far edge of the Goldilocks zone became the cold desert world of dunes and canyons that we know today. And all that it took to tip a once vibrant world full of promise to a cold and desolate dune was the loss of a magnetic field, seemingly such a small thing that not that long ago no one would have thought it possible. Much closer to the Sun than Mars lies the hellish world known as Venus. Though looks can be deceiving, and from space, Venus appears to be peaceful, a serene world of golden and silver clouds, and with the most circular orbit of all the planets, and only 3.4 degrees inclination, a world so close to the Sun must be in an eternal summer. But if we strip away the deceptive atmosphere of the Venusian planet, we see that this world, so close to Earth in size and composition, is a far, far different place. Over 500 million years ago, massive movements of the planet's tectonic plates released incredible volcanism, and about 80% of its surface is covered by smooth, volcanic plains. Yet, despite the once apocalyptic eruptions that rocked the surface of Venus, little to no evidence of current volcanic activity can be seen on that planet. In fact, there is little in the way of ancient geological features at all, including remnants of impact craters, indicating that most of the surface of Venus is relatively young. Venus is closer to the Sun than Earth and much closer than Mars, and every 105.5 to 121.5 years, Venus eclipses the Sun or transits it, passing directly between the Sun and Earth, and can be seen by light-filtered telescope as in the above video. The planet shares its orbit with a ring of dust that appears to have derived from a number of nearby asteroids. It has an atmosphere so dense that probes that have traveled to Venus upon hitting it are slowed by as much as 300 Gs of force. The planet, unlike Earth, has no magnetic field, and its heavy and ultra-dense atmosphere are bombarded by solar wind with such force that particles are stripped away so that the planet has a perpetual coma much like that of a comet. Though thin enough that it is invisible until enhanced as in this false color image, the coma streams like a tail away from Venus off into space and is so long that sometimes minute bits of it tickle the atmosphere of Earth, tens of millions of kilometers away. Of all the worlds in our star system, Venus is singularly most like hell. It is a world that suffers beneath a crushing atmosphere equal to 92 Earth atmospheres and endures a temperature of a blazing 737 degrees Kelvin or 462 degrees Celsius. The planet is so hot that lead and various minerals will literally melt and even evaporate beneath the onslaught of its incredible heat. And its atmosphere is so heavy and dense that even though its winds might be restricted to only a few kilometers per hour, that movement carries as much energy as a mighty storm on Earth. But how? How did a planet in composition so much like Earth turn into the most hostile environment in the solar system? Since 1961, the international community has been launching missions to Venus. The former Soviet Union landed several probes on the surface, and the USA, Japan, and the EU have done a number of flybys and sent a number of orbiters around the planet. Venus is a devastatingly difficult world to study, and between its smelting heat and rain of sulfuric acid, probes that go to the surface don't last long. But those probes have given us a snapshot of what the surface is like, and the orbiters have used radar to peel away Venus' atmosphere and show us the landscape of this world, and allow us to begin to piece together its ancient geology, and the formative processes that transform Venus from something that could almost have been like Earth into what it is now. The planet is roughly 4.6 billion years old, and it is believed that, like Mars, early in its history it possessed oceans of water. Early in the Sun's evolution, the Sun was about 6% cooler than it is now, and at that time, it may be that the oceans of Venus were sustainable. But over billions of years, as the Sun warmed up, its oceans began to evaporate more and more into its atmosphere. Water vapor is a remarkably effective greenhouse gas, admitting and then trapping solar radiation in the form of heat. As the atmosphere warmed, more water vapor evaporated from the oceans, making an even greater greenhouse effect. And as this happened, carbon that would have been dissolved in the oceans and in the landscape began to evaporate as well as temperatures continued to climb. A runaway greenhouse effect was set into motion, boiling away the seas of Venus. And Venus, because it lacks a magnetic field, had no way to shield its atmosphere from the constant bombardments of solar wind. This wind stripped away the lighter gases from Venus' atmosphere, leaving air that is 96.5% carbon dioxide, 3.5% nitrogen, and 0.015% sulfur dioxide, and a melange of traces of other chemicals. This is an atmosphere that is almost custom-made to maintain a greenhouse effect. As if Venus had not endured enough, another catastrophe struck the planet roughly 600 million years ago. There was massive tectonic activity on the planet, which can be seen by radar from space to this very day, as gigantic fissures on the surface, along with the remnants of massive but now extinct volcanoes. In fact, some 167 large volcanoes over 100 kilometers across have been sighted on Venus through radar. By comparison, on Earth there is only one volcanic complex that might even match that, and that's associated with the formation of the Hawaiian Islands. And much of the surface of Venus is now volcanic plains. When this volcanic activity took place, it would have released a massive amount of gases into the atmosphere, which would have added both to Venus' atmospheric toxicity and its greenhouse effect. When it is all said and done, what it means is that Venus became the hell that it is now, due to a runaway greenhouse effect. Its oceans warmed, adding to its atmosphere's greenhouse gases. This encouraged the evaporation of more water, which freed carbon that had been dissolved in the oceans and in rock, increasing yet more the greenhouse effect. Indeed, by the time the massive volcanoes had reshaped the surface of Venus, several billion years later, the planet was long dead, killed by its own greenhouse gases, and a water world with all the potential of Earth became transformed into a dry, hellish landscape of endless baking heat, a realm so hot that mineral snow on mountaintops, and where no life as we understand it could possibly ever exist. Between the dry and cold, broken world of Mars and the desiccated, blazing hell that is Venus, lies the one world that life might consider to be a success story, a rare, blue-green gem of a world of plants and fungi and animal life, offering a varicolored landscape spanning snow-capped mountains, steaming jungles, vast desert dunes, and skies alight with color from the distant stars to the rainbow hues of the aurora. This world called Earth is our solar system's only success story, and for all we know, it may be the universe's success story, at least in terms of intelligent life, or life at all for that matter. For down there, where the shadow of night has just given way to day, lies the only place in the known universe where complex life exists, or any life whatsoever. Indeed, where Mars and Venus failed, Earth has succeeded in surabundance. Life is everywhere, from the plants and trees fed by the sunshine to the depths of the seas, where life, bizarre to we humans, thrives upon heat in a process known as chemosynthesis. But given that 2 of the 3 worlds that share our star's Goldilocks zone have failed, we, who dwell upon this one privileged world, might be wise to ask, why did our world succeed? And if we were to do so, there is an evident answer. For life to thrive, many forces must come to play in a perfect and fragile balance of land, sea, and sky, and a nudge, a mere nudge against any of those, can spiral a once living world into oblivions such as Mars and Venus experienced. Throughout its 4.6 billion years of history, Earth has experienced many such nudges, leading to warm tropical worlds and glaciated worlds. Roughly 700 million years ago, Earth experienced a massive glacial period known as the Snowball Earth Era. Throughout time, there have been various ice ages, but the Snowball Earth Era was different because nearly the entire planet glaciated over for reasons not fully understood. However, the best evidence indicates that the planet glaciated due to massive, decades-long volcanic eruptions which launched sulfur dioxide into the tropopause. At that altitude, the sulfur dioxide was able to reflect considerable amounts of sunlight, cooling the Earth. The northern and southern poles began to freeze over, and a chilling runaway cascade took place. The ice reached all the way to the equator, and complex life on Earth was saved only because a very narrow band did not freeze over. Over time, those same volcanic eruptions that had led to Snowball Earth also led to the period's undoing, because carbon dioxide and methane, emitted primarily by volcanoes but also by the surviving life, accumulated in the atmosphere to levels sufficient to reverse the glaciation. But this was no mean feat, taking between 5 and 30 million years. So Earth slowly warmed and continued to warm, becoming a tropical world. And indeed, over geological ages, Earth has been through numerous periods of glaciation and warm eras. But of all those periods, perhaps the most interesting, and certainly the most relevant to us, is what is known as the Paleocene-Eocene thermal maximum, a catastrophic event in which Earth experienced a massive spike of up to 8 degrees centigrade global warming as incredible amounts of greenhouse gases were injected into the atmosphere in a period lasting under 2,000 years, the blink of an eye in geological time. This event, dubbed the PETM, was a spike in the ordinary climate change of the Paleocene epoch, and as spikes go, it was severe and dramatic. Evidence indicates that over the span of about 1,500 years, some 2,000 gigatons, that is 2,000 billion tons, of carbon were released into the atmosphere, probably due to volcanic activity. It was so much, so fast that the carbon began to act immediately as a greenhouse gas and initiated significant global warming. Temperatures rose so much that the Arctic and Antarctic regions of the planet became the equivalent of modern-day temperate areas. I myself have walked through canyons in the subarctic where one can observe, in rock walls and natural standing stones, carbon fossils that look like charcoal drawings fixed into the rock. The oceans have always been Earth's thermostat, and they began to absorb this heat and the carbon, leading to acidification of the water. Warm water does not hold oxygen as well as cold water, and so the PETM was marked by the greatest extinction of aquatic animals in 93 million years. As the temperatures warmed, methane held beneath permafrost in the polar regions, and also by cool, high-pressure waters deep in the seas, was released into the atmosphere, further exacerbating the global warming effect. And as temperatures spiked, vast regions of the Earth's surface experienced considerable environmental and climatic changes. The PETM was a blow to the biosphere of Earth, which was still recovering from a mass extinction initiated by an asteroid impact some 10 million years before, most famously the cause of the extinction of the non-avian dinosaurs. And the PETM is of tremendous interest to scientists today because it happens so fast, directly as the result of an upsurge of greenhouse gases. And this makes the PETM very similar to the climate change that is happening today, which results from the release of greenhouse gases created by humans. And very alarming to scientists, modern climate change is happening faster than it did during the PETM because humans are creating and releasing greenhouse gases into the atmosphere as much as 10 times faster than they were released during the PETM. To put it another way, if the Paleocene-Eocene thermal maximum event was a blow to Earth's ecosystem, the radical scale of what we humans are doing to our climate now is a bomb, except nobody knows if this bomb simply holds a few sticks of dynamite or every nuclear warhead on the planet combined. So Venus and Mars probably began their ancient histories much like Earth, but for each of them, things went wrong. In the case of Venus, it was simply a little too close to the Sun. The Sun is a G2V class star, a main sequence yellow dwarf. It will burn for many billions of years, but as it burns, it will very slowly get a little brighter and a little warmer. Earth is far enough away that does not much affect its climate, but for Venus, it pushed it over the tipping point, heating the planet just enough to begin a runaway greenhouse effect, which in time slowly turned the planet into a blazing hell. On the other hand, Mars died by little bits. The planet was simply too small, and its diminutive core simply could not maintain a magnetic field sufficient to shield its atmosphere and oceans from the solar winds. So its atmosphere, and then its water, were slowly blown away by winds from our star. Mars dying was long and slow, though it received a coup de grace when it was impacted billions of years ago by a dwarf planet, or a huge asteroid. Earth, however, was luckier than her siblings. She was impacted by another planet long, long ago. It's how we got our moon, but it was before the formative processes that turned our world into a living planet had even begun. And over the 4.5 billion years of her history, she suffered various blows, primarily asteroid and comet impacts and periods of immense volcanism. But each time, our world was able to recover because our planet has a large and active core that protects its atmosphere with a strong magnetic shield. Earth's vast oceans serve as thermostats and help buffer it against climate change. And tectonic activity renews the surface and freshens the atmosphere. But now, there is a new factor affecting Earth's future, we humans. And we are a variable for which there is no precedent. And we are presently doing things to this world that simply have never been done before. Over the last 2,000 years, the human population has been rising at an ever-increasing pace. And with it, deforestation, conversion of land to agriculture, overusage of the seas, and the production of an immense amount of pollution that directly enters air and water. As noted earlier, the pollution that humans create these days is 10 times greater than that which was created during the PETM. And the human carbon footprint is presently 60 times greater than global volcanism. We are throwing greenhouse gases into the atmosphere so fast that scientists now wonder if our environment will actually be able to recover from this blow. It took 1,500 years for volcanism to release its greenhouse gases during the time of the Paleocene-Eocene thermal maximum. And then the climate changed over a span of 20,000 years, enough time for Earth's environment to begin compensating for the impacts. But since 1880, as the Industrial Revolution was really starting to take hold, human activities have already released enough greenhouse gases into the atmosphere to warm it by 0.8 degrees centigrade. The PETM was the worst climate crisis Earth has experienced since the asteroid that wiped out the non-avian dinosaurs. But no longer, for in just 140 years, humans have already altered the atmosphere by as much as it took the PETM 2,000 years to accomplish. And if we humans do not learn to curtail these activities, this will only get worse. And scientists now begin to question, if the atmosphere is hit this hard, this fast, would the ecosystem ever actually be able to recover? There is no historical precedent for what we humans are now doing, and so no really reliable way to model or predict the outcomes. All scientists can in truth tell us at this point is that if we don't change, this one world that we know in all the universe, which managed to become a haven for life, our only irreplaceable world, may not survive us, and if it doesn't survive us, we will almost certainly perish with it. For in all the universe, we know of only one world that supports life, one Earth capable of supporting humans. But even if every other star system had its own living, breathing world, it would make no difference to us. We cannot get there. By our best technology, getting humans to another star, presuming it is possible at all, would take tens of thousands of years, far longer than civilization itself has even existed. We have this one world, and with it, this one chance to do life right. And so we have a choice and a chance. The question is, what will we do with it?